Hi, everybody. Tonight I will be delivering your very last lecture for my class this semester. Thank you all for your time and energy and effort that you've put in. I think you guys are all amazing. You all have very bright futures ahead of you. I know my class isn't exactly what you were studying, for your major, but it's a little addendum to that. And I really just appreciate all of your effort and time. So I wanted to say best of luck, and you guys are all going to do awesome things. So that being said, we're going to actually get into our lesson. The lesson is very short tonight. I like to call it the EKG odds and ends, because it's really just kind of a bunch of weird stuff you might run into, or some things you might need to modify, or special circumstances that you come across. Okay. So let's get right into it. So there are something called right-sided EKGs. You're like, right-sided? Why the heck would I put EKG stickers on the right side? The heart points to the left, right? So if you have something, you're born with something called dextrocardia, and if you're not familiar with that, that just means that your heart was kind of born on the wrong side. It's a mirror image of what you have in your body right now. So right now, our apex points to the left side of our heart, and in someone with dextrocardia, the apex points to the right side of the heart. So they're born that way. It's not like we don't wake up one morning and your heart's like, hey, I think I want to be on the other side. So it's a mirror image. It's kind of interesting. And therefore, if we put the stickers on the left hand side, we're not going to see the same reading we would if we were on the right hand side. So your sticker placement is going to be very similar to a regular EKG, except you're just going to move it to the right side. Doctors occasionally will request that you do one on the right side, even for a normal patient with a regular heart placement, because they suspect maybe a right-sided MI is happening, and they want to just get a better look at the right side. So that's a possibility too. But the most common one is because they just are born with tachycardia. Okay. And I've seen two patients so far, my entire 10 years, 11 years doing EKGs, that have had dextrocardia. One of my students in high school actually had it, and then a patient at the hospital. And you wouldn't know unless they told you or it was on their chart that it was dextrocardia. So something to obviously be aware of, correct? Yeah. All right. So again, they would go on exactly the way. Let me go back one real quick. They would go on exactly the same. So you can see in the picture, I meant to point out the picture. You see in the picture that V1 is going to be placed here on the fourth intercostal space, but now it's going to be on the left side of the sternum, and V2 is going to be on the right side of the sternum. And then V4, 5, and 6 are all on that fifth intercostal space like they were before. They're just on the right side of the patient instead of on the left. And they actually will you depict it with, it's V1R, V2R for right side. So that's how you would tell the difference. And on any exam or review things that I have you do, I would say, where does V2R get placed versus just V2? That means it's a right-sided EKG. So don't get those two confused. Okay. And you would do that with once you print the EKG out, you would write right-sided across the top of the EKG, and you'll write V2R. Next to V1, you put an R, V2, you put an R, a 3R, so that we know that this is a right-sided EKG. Okay. All right, let's move on to posterior EKGs. So posterior means on the back, right? So why would we do a posterior on the back, an EKG on the back? Our heart is, we do have heart kind of in the center of our chest. So if we want to look at the posterior region of the heart, if the doctor suggests or suspects a posterior MI where there's a blockage in the rear, the posterior region of the heart, then they would have us do a posterior EKG. So we actually keep all our limb leads are going to stay the same, and V1 through 3 are going to stay the same. So we're still going to put them on, V1, V2, and V3. And we're going to change V4, V5, and V6. So those are now going to become posterior leads, which is an extension. So V4 will become V7, and that will be on the fifth intercostal space on the back. You can see it's right here. It's left posterior axillary. So remember, our V5 was in the front, was anterior axillary, front of the armpit. This is at the back of the armpit, just behind on the back. Okay, right here. And then V5 becomes V8, and that's also going to be on the fifth intercostal space back there. And it's going to be mid-scapular line. So remember on the front, our V4 was mid-clavicular. This is mid-scapular. And it's usually right at the point of the scapula. So you can see the scapula here, and there's a little point down here. And then our last one's going to be V9, and that's going to be also fifth intercostal, but it's going to be left paraspinal line or paraspinal border, sometimes they call it. So instead of being next to the sternum, it would be next to the spine right here. So you're actually just going to keep V1, 2, and 3 right where you found them. And where V4, 5, and 6 would be, you're going to put them on in the back. Okay. So once you put them on the back and you have them do their EKG, and I know you're thinking in your brain, and Rochelle, I'm thinking of you, in your brain, well, if they're on their back, how come they're going to lay on their back? And I'm going to do that. I'll explain it in a minute. So you would then cross out, once you print it out, you're going to cross out V4, 5, and 6, literally cross them out and put V7, V8, V9, and write posterior EKG across the top in big letters so that the doctor reading it knows that this is a posterior EKG, not a regular one that we would normally do. So in your brains, I know you're thinking, so if I have some on the front and on the back, how do they lay on the bed, right? Well, they definitely can't be at an incline. I would lay the bed down nice and flat first, and then put the 1, 2, and 3 and the limb leads on, and then have them roll to their right side. That gives you access to the back on the left side, and you can put 4, 5, and 6 back there. It's actually 7, 8, 9. Hook those up and then have them just lay as still as they can on their side, which is called recumbent. We're going to talk about those in a minute here. So that's the best way to do it. Start on the front, get the stuff on the front, and then roll them to their side, put the ones in the back, then have them lay still while you get that posterior EKG. Just make sure that you're noting it on the top that it's a posterior EKG, and you've crossed out V4, V5, and V6. It made it V7, V8, and V9. And you're good to go before you present it to the doc. Okay. I actually have done quite a few of these. This is not as uncommon as you would think it would be, and it's usually to rule out a posterior MI. Mm-hmm. They see something funky on the front. They have really strong symptoms. So you'd see it probably really deep depression. And it looks like if you flipped it over, like if you took it and turned it upside down, it would look like ST elevation, but it's just really deeply inverted. Not inverted, but deeply depressed. And you turn around and do the posterior MI and you see the elevation because it's in the back, which show a mirror image. And that's how you can confirm it or not. If you have more questions about that, send me a message or whatever. We can talk about it on Zoom or when I see you in person next week on the 10th. We can ask him. I can clarify all that on the 10th as well. All right, so Holter monitors. Holter monitors are something that a lot of patients wear, definitely cardiac patients wear in the hospital. But these are ones that you can actually place on a patient they can wear home also. So most Holter monitors are placed on a patient that having some sort of arrhythmia or they know that they need to be monitored because they go in and out of weird rhythms, like, it might be rapid AFib or SVT or VTAC. It's just to monitor the patient to make sure they don't go into a bad rhythm. And then when they do, we can capture it through the Holter monitor. Okay. A lot of these, the small devices that with the outpatient ones, they wear for 24 to 48 hours. And to be honest, as a tech, I noticed that we don't really get a lot of information from the 24 to 48-hour ones. It's much better when they can wear it for several weeks at a time. You get a better pattern and understanding of what's happening, certain times of day and stuff like that. So I wore mine for a month. I had to wear one because I was having frequent PVCs. And my doctor, after 3 weeks, she's like, okay, listen. She's like, I'm literally getting 27 pages of PVCs daily. So I think we know what it is. We can stop wearing it. But it gives them the right information. So they have it. It's not just a random 1 or 2 days worth of stuff. It's a regular, I'm going through my regular routine throughout the week, exercise, all that stuff. So it's important to get all the information. So the little device will actually record every single heartbeat because it's hooked up to you. It records every single heartbeat, and then the recording gets either stored in the device or stored in the cloud. If you have a long-term device, it just gets sent out periodically through cell phone service, And if you have that small one that's only 24 to 48 hours, everything's recorded on that device. They bring the device back to us, and I will plug it into my computer and download all the information for the doctor. And that's one of my jobs. And then it's like I scroll through all these beats very quickly and try to find things that don't look right. So we interpret it and then we send it off to the doctor for review. That's the 24 to 48-hour one. The 4-week one is typically one that goes to the internet, so or cell phone service, and it gets kind of sent out each day. And my doctor was getting the report every day. She said it was kind of driving her crazy. But you can see it's worn here on the chest. This one happens to be a 5-lead one. There are 3 and 4-lead ones as well. So here's a picture of that. So there are 3, 4, and 5-lead. The ones that we have at the hospital for inpatients, because I do wear these monitors in the hospital also on different floors, is a 5-lead halter. Okay, or they just call them monitors. Sometimes they just call them cardiac monitors. But if you have a 3-lead, notice it's the 3 limb leads that we use. You just put them in those spaces, and there's our Anthopus triangle, right? So it's just going to be the right arm, the left arm, and the left leg. If you have a 4-lead one, it would just be the 4 limbs. And if you have a 5-lead one, which is what most of ours do at the hospital, you'll see they are color coded, just like our regular EKG wires. Okay, so you'll see a white one, a red one, a white one, black one, red and green, and then you'll see a brown one. A brown lead is only on a monitor. It's not on a 12-lead EKG. But the brown lead, when you have one, goes center chest, just somewhere in the center. Okay. If on your test it's or an exam, the center chest isn't an option, it would be V1 or V2. So in this area here is where that brown lead is going to go, somewhere right here. Okay. Then you have the limb leads, and you have all 4 leads, and we're good to go. I've seen them people usually put them like back here on their shoulders. I don't know why they do that. I guess because it leaves them more room to work up front. Your echo techs, I probably would get mad if I put stickers there. So maybe the echo techs like them up there. You guys can tell me later, I guess. But it does maybe gets in the way, so they just put them in odd places. Remember, limb leads really can kind of go anywhere, right? Yeah. Okay, so here are the patient rules for a monitor. Whenever they're wearing a monitor, especially when they take home. In the hospital, we are with them. We see them every day. We can, remind them of the rules and things like that. They're there to ask us questions. But if they're taking it home, they need to know that they cannot get this thing wet. It's an electronic device. Just like you wouldn't put your cell phone in the bathtub, you wouldn't put a halter in the bathtub. They can't shower with it. They can't bathe with it. So biggest thing, they can't go swimming and all that. So if they're wearing it just for 24 to 48 hours, we just tell them, please just don't get wet for the next 24 to 48 hours. If you're wearing it long term, obviously I could shower. I would take it off when I showered and put it back on. So you as the tech or myself as the tech, I have to coach the patient on how to do that by themselves at home. Again, I wore it for almost a month. So the stickers, if I kept putting in the same place, would make my skin really irritated. So I would try to switch out the stickers daily, and I just move it in a little bit different place. So if my 2 limb leads were here, I'd move them up a little bit next day, or move them over the next day, move them down, kind of move them around in the same vicinity, just in a different place. So I wasn't getting that redness to my skin. It really got kind of itchy and raw in a couple places. So you have to wear it every day. You can't reposition it. Um, they want you to do all your normal activities. So they want you to exercise regularly. They want you, unless it's swimming, of course. And, but if you walk every morning or lift weights, do CrossFit, they want you to wear all that. Wear it while you're doing that so they can see any arrhythmias you might go in and out of doing your daily activities. Okay. And then if you're having any symptoms related to these arrhythmias, some people have lightheadedness, dizziness, palpitations. You would note that in this little journal they give you. It's just a little paper journal. If they don't have any symptoms, they don't write anything in the journal. It's pretty simple to do. So they would write down Wednesday at 5 p.m. I felt palpitations. So me as the tech, when I'm going in to read the EKGs, when I download all the information, I'm going through it. I'm going to look Wednesday at 5 o'clock to see if I saw anything that looked weird. Maybe I see SVT at that point. Maybe those palpitations were really just SVT, and I can see what happened at that time and correlate those that information together. If there's no symptoms, they just leave it blank and turn it in and say I didn't have any symptoms. I'm still going to scroll through every single beat. What the journal does in the symptom journal is just kind of helps me look a little bit easier. But I have to look through them all anyway, so it doesn't really matter. All right, so they do use different names for these monitors. They might be called a Holter monitor, a cardiac monitor. They might be called a telemetry monitor, an ambulatory monitor. They all mean the same thing. They all do the same thing. They all mean the same thing. So if you see these interchangeably around in the facilities that you work in, at Christiana, it might be called a telemetry monitor, but if you go to work at St. Francis, it might be called an ambulatory monitor. They're all the same thing. Okay, don't get confused. I know AI has, they use monitors also. Whatever different facilities may use a different name, but they all mean the same thing. They all have the same job. They all have the same restrictions, like getting it wet, to try to keep it on, do all your regular activities, and any journals if you're taking it out of the facility. Okay. And this guy is kind of hooked up kind of weird. I looked at this one, I was like, who did this workup? But this is your limb leads, and they put the brown lead way down here. So I'm not exactly sure who did this or why, but it's not standard. It just goes to show you that everyone does something a little bit different. I do see them on the sides quite often. Again, I think that's to leave room for other things going on. If they need to put AED pads or if they need to have an echocardiogram or whatever, this stuff would be in the way. So they kind of try to keep it away from that area where they would want to do more work. Okay, that's my best understanding of why they kind of look like this in different places. Okay, but that brown one's supposed to be in the center. All right, so medical positions are important, and I'm sure you've learned these before, but in EKGs, you have to think yourself through if I'm going to do an EKG on a patient, I want to make sure number one, the patient's comfortable. If the patient's comfortable, then they're going to lay still for me, right? So I don't get any artifact. Patient's uncomfortable or in an awkward position, I'm not going to probably get the best EKG. So the standard position for EKGs is supine position, laying nice and flat. Okay. I don't ever lay patients super flat like this. Most of the time, I do not lay them 100% flat. It's harder for them to breathe. A lot of these patients are sick and they're here for other reasons and they can't breathe. So I usually elevate a little bit. But if you're asked on the test, this is the standard position for EKGs, supine. And then prone is face down. This is not typically an EKG position used until COVID came along. And I think you guys maybe have noticed or learned throughout your schooling here that we've put patients that have COVID, severe COVID, in the prone position a lot now because it's easier for them to breathe. They learned that this is a position that actually allows them to breathe better when they have COVID lungs. So to do an EKG on a prone patient, you typically need some help. They'll have to turn the patient over, or you would do a posterior EKG. So if you walked into a room like this and you were supposed to just do the EKG on the patient, I would ask for some help and guidance. Is it okay to take them off the prone position? Is there a nurse or someone that can assist me do that? So it's not typically used for EKGs unless now that we have this COVID thing, I've had to adapt occasionally to this. Just always ask for help if you're going to try and do something like this without knowing what the patient's history is and everything and why they're in this position. Always ask the nurse that's in charge of that patient. And that's in anything you guys do. If you guys have become echo techs, you become respiratory techs, converse with the nurse. They know what's going on with that patient and they can help guide you and help you, do whatever you got to do. So the lateral recumbent one is used for posterior EKGs. This is on your side. I mentioned that earlier. It's called lateral or recumbent when you're laying on your side. Start the patient on their back, put the stickers V1 through 3 and limb leads on first, and then roll them to their right side, which allows the left side to be sticking up. And you can put those V7, 8, and 9 on their back really easily on the left side. So that is used for posterior EKGs. If you need to make them comfortable because they're not so good laying on their side, you just prop some pillows up like this, and that typically helps them hold still so you get the best EKG you can get. Okay. Then there's the Sims position. I put this on here because it was one of the certification exams I took, and I didn't really know. I remembered what Sims position, but I didn't remember. I got them confused between semi-Fowler and Sims. And Sims positions for rectal exams, it's not for EKG. So I'm going to skip over this. I use the same presentation for my students that are sitting for the EKG certification exam. And Sims position is not one we do an EKG in. However, we do use the Fowler and semi-Fowler, and most of your patients that you see in the hospital are in this position already because they're in a hospital bed, and they're typically inclined a little bit, right? Because it's a comfortable position for them. But anyone that has some sort of lung issue like COPD, asthma, COVID, would be in this position already just to help them breathe better. So it's a 60-degree angle is the Fowler position, and then a 45-degree angle would be a semi-Fowler. So this is semi-Fowler and Fowler. Whatever makes them a little more comfortable to breathe better, that's what you're going to do. Okay. Do I mean you have to actually measure that, get out a protractor and measure that 60 to 45-degree angle? Absolutely not. Somewhere between there is good. Anywhere in there, as long as they're easy to breathe. I've actually set people almost straight up before because they're just having such a hard time breathing, either COPD or pneumonia or something happening. And the harder they are having to breathe, the worse picture I get because I get now that wandering baseline and some wiggles and stuff. So the more comfortable they are, the better EKG we get. Just work with the patient on that. Okay. Stress testing. Now, you nuclear medicine people and then echo techs are also going to be involved in stress testing. So the respiratory were the only ones that aren't involved in stress testing, but you may come across it and need to know what it is. Okay. So stress testing, when we do this on a patient, um, it used to be we walk on a treadmill. It used to be like just about everybody walked on a treadmill. We don't have as many walkers as we used to. A lot of our patients are older and more fragile and frail, and they just can't walk on a treadmill anymore, especially on an incline. So, but if they're young and healthy and have the mobility, then we're going to put them on a treadmill. And that treadmill stress test is called Bruce Protocol. It is a universal protocol throughout the world, and it's set already for you to go a certain height and speed every 3 minutes. It goes a little higher, a little faster. It's a maximal effort test. I tell my patients that every time they do this, maximal effort test. You need to go as far and as long as you can until we have symptoms that make you stop or we reached your target heart rate, whatever we need to do. So whenever you exercise, anyone that exercises, there's something called the maximum heart rate and the target heart rate. So maximum heart rate for anyone exercising is 220 minus your age. So that is the maximum heart rate you should ever exercise at for any extended periods of time. So it's okay to go over it a little bit, but you shouldn't do that for an extended period of time. So, like if you are 30 years old, then your maximum exercise heart rate should be no higher than 190 for any extended period of time because it's 220 minus your age. Okay, so you can figure that out for your own age. That's your exercise capacity, your exercise max. Okay, so our target heart rate in stress test is 85% of our heart rate max. So again, if you're 30 years old, I'll get my calculator out. So 220 minus, we'll take 220 minus the age, minus 30 for age, and I get 190. And then I'm going to multiply times 0.85 because that's 85%, correct? That gives me 161.5. So the target heart rate for this patient that's 30 years old is 161.5. We need them to get to minimally to 161.5. So that's our minimum target. So they can get anywhere between 161 and 190 to have a good test, knowing that we actually exercised you to a capacity that gives us good information about whether your heart is under any stress when you exercise. Okay, so that's what a stress test is. It's just looking to see how the heart handles stress, and exercise is stress on the heart. So that's how we do that. You take EKGs and blood pressures throughout the test. We look for normal blood pressure response to exercise. And in exercise, I'm not sure if you've learned this before, probably. In exercise, normal blood pressure response is that the systolic blood pressure will increase and the diastolic blood pressure will actually decrease. And the diastolic will decrease because when you exercise, a natural phenomenon that happens is those blood vessels vasodilate. And it does that so that the blood oxygen can get to your muscles and your organs faster and just make them work at higher capacity. Okay. So, um, normal blood pressure response in exercise, systolic goes up, diastolic goes down. That's how we're looking for. We're also looking to see if there's any changes in the EKG, like ischemic responses. So we're looking for ST depression or T waves that flipped upside down, if you remember from our ischemia and infarction unit. And occasionally we'll see some peak Ts that happen from exercise. Mhm. So we're looking for all that, and then signs and symptoms they feel, and then the reason they needed to stop if they just were too tired or too winded or we got their target heart rate. And then in the EKG changes are noted. So obviously, if they can't do a treadmill, we're going to give them that pharmacological test, which I believe we did talk about before. Um, can you calculate your target heart rate for a stress test? You can do that on your own. So again, it's 220 minus your age. That's your max, heart rate max. And then it would be times 0.85 for your target. Okay. So this is the different stages of Bruce protocol. And again, like I said, it's universal. Whoever, no matter where you go, it's going to be the exact same thing. And the guy's last name was Bruce. It wasn't his first name, by the way. I don't know his first name, to be honest. It's Bruce protocol. And it is universal. You go to the UK, you go someplace overseas, it's going to be the same. So it starts off pretty slow. It's 1.7 miles per hour. That is pretty darn slow. If you ever gotten on a treadmill and tried to go 1.7, you're like, wow, this is really slow. But it's at a 10% grade. So it's on a pretty good hill. And again, you can play with the treadmills at the gym. If you've ever taken it to 10%, you realize that's actually pretty high. Treadmills at the gym only go to 15%. This Bruce protocol goes to 22%. What? I know, it goes really high. Most adults um, in their age bracket, go between 7 to 8 minutes. The walkers anyway, that 50 to 65, 70 range will go about 7 to 8 minutes. Some go a little less because they're just not conditioned. Some go a little bit more because they're athletes already and they exercise regularly, and this is something they do on a regular basis. So it just really depends on, their regular everyday activities, their exercise capacity, and then the obvious outcome of their heart, so long as their heart's in good condition. Okay. So this is what they have here, and it's going to be stage one, obviously, is 3 minutes. It's a 10% grade at 1.7 miles per hour. And then it gives you the METs as well. But you can see all the way along, it goes a little bit faster, goes up by 2% grades, and it goes to 2.5, then to 3.4, then to 4.2, 5.0. By the time you're here at 6.0 at 22% grade, you are running up a hill, like running. I have only ever seen two people complete this test ever in my entire 11 years. One of them was someone in my class, and they were a marathon runner. And then we did an 18-year-old soccer player that was getting severe chest pain when he was exercising, when he was running. So the doctor wanted us to run him, just run and run and run. So he did, but he did great. So that doesn't happen very often. All right, this is just kind of what the stress test looks like. So let me explain a little bit between the two. So a nuclear medicine stress test and a stress echo are a little bit different. They both involve pictures of the heart, just two different ways to take pictures before and after the stress part of the test. So in a nuclear medicine stress test, the patient is injected with a radioactive material that has the body emit what's called gamma rays outside. They emit gamma rays. So they lit under a camera and they take about 15 minutes of pictures of their heart at rest. Then we go and exercise them. We'll exercise them on the treadmill until they reach their target heart rate and or they get too tired to go. We want them to get to that, at least to the target. We'll inject more of the tracer because now they've exercised and their blood vessels are nice and wide and open. And the tracer will go in and hopefully marinate around and travel around really quickly. And then we stop the treadmill test, and then we'll go under the camera again and take a set of pictures. So I've looked at these pictures, the nuclear medicine stress test, and I got to tell you, they look like constellations to me. I have no idea what I'm looking at. I can understand the PET ones a little bit better because it's more like a CT scan, but these are confusing. I have no idea what I'm looking at. So if you can read that, you are amazing. That is your skill, and I applaud you. As far as the stress echo goes, they're going to do an ultrasound picture of the heart at rest. And so that's a different way to look at the heart. So we're looking not necessarily at the heart arteries that surround the heart, but we're looking at the heart function. So those valves opening and closing, the ventricles squeezing, and you're looking at how effective that heart is at rest. And then we will exercise them. So we'll exercise them on the treadmill, get their heart rate up to where we need them. I stop the treadmill very quickly. They jump back on the bed, and then you, very skilled echo techs, will go in and take a picture of the heart as it's beating fast. So you can see again the ventricles squeezing, the valves opening and closing, and hopefully you can see how effective the heart is while they're exercising versus at rest. Okay, so I have a hand in both. Typically, those the nurses can step in and do that in different facilities. Sometimes the nuclear medicine techs actually run the stress test. Believe it or not, they do everything, which is kind of crazy. Yeah, I know it's crazy. So that is stress tests in a nutshell. You guys have this presentation also on your D2L. If you want to watch one, this is a video of an actual stress test happening. I think all of you have probably seen one. At least two of you guys have seen one in action, and if you haven't, you will be very soon. And those respiratory, if you want to kind of see what it looks like, this is a video of one what they look like. Okay. They can see they're hooked up to the EKGs, the 12 leads. They are modified off the arms and legs to be moved to the shoulders and belly. This clearly is not a stress echo because when we stop to do this one, the echo tech would need to put um, the transducer right here. So these stickers are in the way. So when I'm prepping for a stress echo, I'm going to take these stickers and I'm going to move these a little bit higher and I move these a little bit lower. So I might move down to the 6 intercostal space just to give that echo tech some room to put the transducer and get a picture of the heart beating properly. Okay. So don't be surprised if we modify it even more depending on what's happening with the patient. All right, I think that's everything. I covered everything. Holy moly. Yes, I did. All right, so that's it for me for tonight. Enjoy your week. I will see you next week in person for our very last class on the 10th of April. And if you have any questions in between, I will be available on Zoom Monday night tonight, which is the 3rd from 4:30 to 5:30. If you join, you join. If you don't, you don't. That's fine. I'll be on Zoom either way. And then I will see you on the 10th for our very last hurrah. All right, guys, have a great week. I will see you soon. Take care. Good luck with everything. Bye.